Here is how Unger can monitor the tank values in real time, straight from the production facility in the simple web page for lye and sulfur in this case, which is the registered tanks. You have current level, current usage, and predicted runout. You can see predicted usage for specific dates there for sulfur. You have history, you can make an order, and you can add maintenance. This can be used by the suppliers, and they will see their own tanks only. Here is how the communication technologically is facilitated. We have used the management tool from Arrowhead to facilitate communication between a supply consumer delivering the information to the web interface for suppliers and for Unger. From the factory side, the information are going to the API's producer, and moreover, the communication is encrypted using the certificate authority coming in the Arrowhead framework box, and self-signed certificates for the consumer and the producer ensures the encryption.
Here we see the main menu, where the operator can choose the different sequence program that should run to control the process. Each sequence program has its own parameter adjustment that the operator can edit. From the screen, the operator can start the program by pushing the start button. Further on, the operator can follow the steps that the sequence program are doing, showing in highlighted text. Before the productive project, the operator had to watch the C-glass and had to call the main control room to manually make the transition. This has been translated into code and been replaced by machine learning to see the transition. We see the color in the glass changes, and the near instrument is translate this to a fingerprint. This fingerprint makes a trigger that we will use to make the transition point between the product change. The screen is split into 3 different sections, where the first section contains a real value from process. In this case, the value is extracted from Unger historian server. In the middle section, they are showing the process flow as simple graphical figures. That explains different section in the factory. In the lower section, we have the estimation value from mass balance program and from the machine learning algorithms. The first column of prediction belongs to the first section of the process. The second column belongs to the second section of the process and further on. Here we see the program is running, and we see the production are shifting from one storage tank to another. In this condition, the program is starting the accumulation from starting point of its values.
The Unger control system is connected to an API's Prediktor Edge node. By utilizing the powerful combination of Arrowhead, Prediktor Edge, and other communication technologies, we can connect data from the plant network to outside computers and even cloud-enabled services in a secure yet flexible manner. This allows flexible use of the models either as real-time calculation services or as prediction tools.
In this demonstration video, we see the packing of big bags and where we put the sensors inside the bag. The sensors are tied up in a thread and put into the big bag. The single sensor is placed outside the bag. This is a battery package that we used during the big bag transport from Unger. This package we placed in a fixed pallet.
The sensor data is collected by Tellu IoT from the outside network and transferred to the production network for storing and analyzing. The data is stored inside the Tellu cloud. Here we develop the producer and the consumer systems which are responsible for transferring the real-time sensor data to ABIS software. We also exploit the service provided by the autonomous orchestration system to analyze the data. One example of this policy is to notify the operator whenever the temperature or the humidity exceeds a certain threshold.
During the transportation of big bag, we have the opportunity to track the data with GPS signal, temperature, humidity, pressure and acceleration. We also have the opportunity to zoom chosen area of interest to inspect what was happening and where these were happening. The data is stored and we have programs that transpose this data to a time series dataset. This dataset is used to train a random forest machine learning algorithm, and we have made a prediction of what is happening inside the Big Bag by using a reference sensor outside the Big Bag.